Today we're going to be talking about geometric mean. So in our last chapter we looked really carefully at a bunch of proportions. And we said that in a proportion that these numbers in these locations are called the extremes. And we said that the numbers in these locations are called the mean. Okay? And we're going to be using those terms a lot in this chapter, so you need to be sure that you're really familiar with what we mean here. And so, as we look at the geometric mean, we are trying to apply some new techniques to our proportions. Okay, so somebody said, what if instead of having A times D equals B times C, which is what we said we could do in our last chapter, what if instead of doing that, how about we change this B and this C here, the means, what if they were the exact same letter, okay, or which represents a number, right? So they're the exact same number. Then we would get that we have A times D is equal to X times X, okay? So we're going to take a look at what we can do with this particular equation on the next slide. Okay, so we have A times D is equal to X times X. Okay. Well, first of all, we notice, okay, X times X, that's going to give us X squared. And A times D, that's just AD. Right, we don't have to write the multiplication symbol there. Well, what if we had A and D and we just wanted to find out what is X? Okay, so we know that in order to get rid of the squared symbol here, we have to take the square root of both sides. So we're going to go ahead and do that. And we know that over here on the right, that will cancel out the squared, so we're just going to be left with X. And over here on the left-hand side, we're going to be left with the square root of AD. And if we know what those numbers are, we could plug them in and we can solve, right? So they might ask you to find the geometric mean between two numbers. Okay, those two numbers are your extremes. So we're going to think about this as our formula. Our X stands for the mean. Sorry, and that doesn't need a parentheses around it. And our A and our D are our two extremes. So if we were writing this out in words, we would say this would be extreme times extreme. And you can think of these two as your formula for finding geometric mean. Okay? So we're going to plug in some numbers. So for example, what if they wanted us to find the geometric mean between 8 and 10? So these two numbers are our extremes, and the two numbers that they give you will be the extreme. And we're going to just plug them into our formula. So we know our mean is going to be equal to those two extremes multiplied times each other. Okay? So we go ahead and we're going to solve now. So we know 8 times 10 is 80. And if you type that into your calculator, you're going to get a nice long decimal. Okay? In this case, your decimal will be something like 8.944279191. And so if they ask you for a number that's rounded, then this number would be fine. Okay, it's rounded. If, however, like most of our problems, they do not ask you to round it, but they instead want a simplified radical, you need to make a factor tree. So we can go back, we can say, okay, that would be 8 and 10. We know it's 8 and 10 because that's what we multiplied in the first place to get there. Can break these down farther. And what we're interested in is we want to get these numbers broken down as far as we possibly can. Okay? At that point, we stop caring about any number that's been broken down, right? So all of these numbers that I'm crossing out here, they were broken down into other numbers, so we don't care about them anymore. They've been used, we're not interested. We're only interested in the numbers at the bottom of the factor tree. So I have a pair of 2's, I have another pair of 2's, and I have a 5 that's all by itself. For each pair, I can pull out one number. So for this pair of 2's, I can pull out a 2. For this pair of 2's, I can pull out a 2. And for the 5 that does not have a partner, it has to stay inside the radical. If I have more than one number on the outside or more than one number on the inside, then they get multiplied. So the numbers on the outside get multiplied, so 2 times 2 is 4. And there's only one number inside the radical, so that is 4 square root of 5. Now, if you already typed into your calculator the square root of 80, and you're thinking, geez, I just wasted 3 extra seconds of my life, here's where you can use that to check your work, right? We said up here that this would give us 8.94, right? Guess what? If you type in 4 square root of 5, it will give you the exact same decimal. So you can't use the calculator to do all of this middle work here, right? But you can use it to check and be sure you didn't make a mistake. For example, if you had left one of the 2's on the inside, okay, or you had written down a 3 instead of a 2 somehow, or you had not done your factor tree correctly, then typing in this 4 square root of 5 at the end would help you figure out that you had made that mistake, okay? Now, we can also apply this geometric mean idea to some right triangles. Okay, so if we're looking at a right triangle, and we draw an altitude from the right angle straight across to the hypotenuse, okay, then we are going to know that 3 things are true, and you can think of these as being like a formula, okay? What I have on the screen here right now is going to be what you are given for any quiz or test in this chapter, okay? So you don't have to memorize it. You'll be given this part. This is like your formula triangle and the 3 formulas that come with it. And each of these are created because when you draw that altitude, you get 3 similar triangles, okay? So you have the original large triangle, okay, and I'm going to outline these in a color and then I will erase them, just making sure you can see them. So we have the large right triangle, that's our first triangle. We have our triangle over here on the left, that's our second triangle. And we have the triangle here on the right, that's the third triangle. So those 3 triangles are similar. And we said in our last chapter that when we have 3 similar triangles like that, we can set up some proportions. And so these are all based on the proportions and the geometric means that they create. And those are explained more in depth in your book. And I'd be happy to look at those with you, and we'll talk about them a little bit tomorrow in class. But you need to know for now that this page is what we're going to consider our formula, okay? So you are going to be given some questions in your book, right? And they're going to look something like this. And your first step is going to be to copy that picture down into your work, okay? It's really important that you write them down. Please don't write in your textbooks. That makes it harder for other people to learn in coming years. And so we're going to draw out the picture straight from the book. Then we're going to take a second color and we are going to look at our formula triangle, right, on this slide. And you're going to notice over here on the left, it's marked with a B. So I'm going to mark this as B. On the right, it was marked as A. The altitude is marked as H. This section is marked as X. This section is marked as Y. And then they actually have the entire hypotenuse of the large triangle is marked as C. Okay? In some cases, like on this one, you can actually find what C equals because they've given you the 2 pieces to add together. So C is going to equal 30. Okay? From here, we can plug these into our formulas that we were just given. Right, so we have H equals the square root of XY. We have A equals the square root of YC. And we have B equals the square root of XC. Okay, so we were told that H, right here, is equal to E on our original. right, e. X is 6, and y is 24. Okay. For the next one, we have a is the same thing as f. Y is 24. And c, we figured out, is 30. Okay. Finally, we have b is the same as d. X is 6. And c is 30. Okay. To solve each of these, our first step is going to be to multiply the numbers inside the radical. All right, so on this one you get square root of 144, which is a perfect square. So we're going to know right off the bat that e equals 12. Right? F, we're going to find out, is the square root of 720, and we're going to talk about, or we're going to review, I guess I should say, how to simplify that tomorrow, so that you get 12 square root of 5. If you don't know how to do that, I'll remind you about that tomorrow. So that's F. And then D is going to give you the square root of 180. And when you simplify that, you get 6 square root of 5. And again, that's what D equals. So we have these three answers here. And if you remember how to simplify your radicals, then you're good to go. You can go ahead and get started. And if not, we will look at simplifying radicals a little bit more tomorrow. And I really appreciate you watching. Thank you very much. And I hope you have a lovely afternoon. Goodbye.